Hello there, and welcome to The Sleepless Scientist. Tonight we embark on a gentle voyage across the vast, shimmering expanse of our home galaxy, the Milky Way. Close your eyes for a moment and imagine the soft, ethereal glow of countless stars stretching endlessly in every direction. This is a journey not just through space, but through time. A reflection on the cosmic threads that have shaped our understanding of the universe, and in turn, our place within it. From the earliest whispers of starlight, noticed by human eyes, to the sophisticated telescopes that now reveal secrets hidden for billions of years. The Milky Way has been both a guide and a mystery. As we move together through its spiral arms, we will explore its structure, its rhythms, and the quiet wonders that lie beyond the reach of daylight. Let this be a time for curiosity, for awe, and for the calm that comes from looking up at a sky that has inspired generations. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. The home galaxy of humanity. At first glance, the Milky Way seems like a mere streak of light across the night sky, soft and unassuming. Yet within that faint ribbon lies a staggering complexity. Our galaxy, home to hundreds of billions of stars, vast clouds of gas and dust, and the gravitational choreography that binds them all together. We are tethered to this immense structure, our solar system tracing a quiet orbit around the galactic center at unimaginable speeds, yet we barely feel the motion. The Milky Way is not just a backdrop to human life, it is the stage upon which all cosmic dramas unfold, from the birth of new stars to the slow, inexorable recycling of matter across eons. It is humbling to consider that the very atoms in our bodies were once part of this stellar dance, forged in the hearts of long-dead stars. In this sense, every one of us is intimately connected to the galaxy that cradles our world, a small but integral note in the grand symphony of the cosmos. How the Milky Way got its name. Think about this. The soft, milky streak we see on clear nights, inspired a name rooted in ancient imagination. To the Greeks, it was the Galaxias Kyklos, or Milky Circle, a reflection of its pale, flowing light stretching across the heavens. The Romans adopted the name Via Lactea, or Milky Road, suggesting a pathway of stars carved through the night sky. The name evokes both the simplicity of its appearance and the mystery hidden within its glow. Across cultures and continents, people have looked up and woven stories around this celestial river. Some imagined it as spilled milk from the heavens, others as a bridge for spirits or gods. The name, gentle and evocative, carries with it a sense of wonder that transcends language, linking human curiosity to the universe's quiet majesty. It reminds us that the act of naming is in itself an act of reverence, a way to claim a small understanding of something far greater than ourselves. The first civilizations to map the stars. Long before telescopes or satellites, early civilizations charted the stars with care and intention. The Babylonians recorded the motions of planets and constellations, using their observations to guide agriculture and ritual. The ancient Chinese compiled meticulous star catalogs, their inked markings bridging heaven and earth. Across the deserts and plains, the indigenous peoples of the Americas traced patterns in the night sky, stories intertwined with navigation and survival. Mapping the stars was not merely an act of science, it was an expression of our desire to find order and meaning in the infinite. Each line drawn, each constellation named, was a thread connecting human consciousness to the cosmos. In this quiet reflection, we can imagine ourselves as part of that continuum, gazing upward with the same wonder and patience, learning from the distant lights that have guided generations. The Milky Way, seen from Earth's darkest skies. Here's something surprising. The Milky Way reveals its true splendor only when freed from the glow of modern civilization. In the darkest corners of the Earth, far from city lights, it arcs across the heavens in breathtaking detail. Individual stars pierce the darkness, and the galactic core shimmers with an ethereal golden haze. Looking up from such a place, one can almost sense the gentle rotation of the galaxy, the slow unfolding of its spiral arms over millions of years. The experience is humbling and intimate at once, a reminder of our smallness and our connection to the cosmos. It is in these quiet, unspoiled skies that the Milky Way whispers its stories most clearly, inviting us to pause, breathe, and contemplate the vastness that surrounds our tiny, fragile world. The scale of the galaxy compared to our Sun. Consider, for a moment, the scale of our home galaxy. The Sun, a star we know intimately, is but a single bead in an ocean of hundreds of billions of stars. If the Milky Way were a city, our Sun would be a solitary candle flickering in a vast, sprawling metropolis. The distances between stars are staggering. Light itself takes tens of thousands of years to traverse from one edge of the galaxy to the other. Yet despite its enormity, the galaxy moves with an almost graceful rhythm, the stars tracing orbits dictated by gravity and momentum. This scale can feel abstract, almost impossible to grasp, but it grounds us in a profound truth. Our existence is woven into a tapestry far larger than ourselves, each star a companion in a slow cosmic dance that has been unfolding for billions of years. The shape of a spiral galaxy. Let's go back in time and imagine the Milky Way as it might appear from a vantage far above the galactic plane. From this lofty perspective, it takes on the form of a graceful spiral, its arms curling outward, like delicate, luminous ribbons unfurling across the cosmos. These spirals are not simply decorative. They are the visible traces of immense gravitational currents, sweeping stars, gas and dust along in a slow, mesmerizing dance. Each arm carries stories of countless stellar births and deaths, regions dense with young, hot stars glowing in brilliant blues, and older, cooler stars settling in amber clusters. As the galaxy rotates, the spiral arms maintain their shape through a balance of centrifugal forces and the pull of gravity, a quiet choreography that has persisted for billions of years. To consider the Milky Way as a spiral is to glimpse a pattern of extraordinary complexity and subtle beauty, a structure that whispers of both order and movement across incomprehensible spans of space and time. Even from the ground, through the Milky Way's soft, milky band in our night sky, one can feel this elegance, sensing the underlying spirals as if tracing them with the mind's eye, imagining the paths of stars we will never individually know, but whose combined light we can see. Why the Milky Way is warped. At first glance, one might imagine the Milky Way as a perfectly flat disk, like a celestial vinyl record spinning silently in the darkness. Yet it is not. Observations reveal a gentle warp along its outer edges, as if the galaxy itself were bending under unseen currents. This subtle undulation is evidence of interactions and histories that span billions of years. Past encounters with smaller satellite galaxies have tugged at the disk, nudging it ever so slightly. Invisible dark matter exerts a gravitational influence that cannot be seen, but whose presence is felt in the galaxy's overall motion. Even the slow reverberations of cosmic forces, echoes from collisions and gravitational waves, leave their imprint on this warp. And in this bending of form, there is a quiet poetry, imperfection, that hints at a dynamic universe, a galaxy alive with history and still evolving. For those who contemplate the night sky, the warped disk is a reminder that the cosmos is not rigid or static. It breathes and flows, shaped by forces both gentle and violent, a living system unfolding on a scale that challenges human comprehension. Counting the billions of stars. Think about this for a moment. The Milky Way is estimated to contain between 100 and 400 billion stars. Each one is a luminous sun in its own right, a sphere of nuclear fusion, blazing steadily in the darkness of space. To count them individually would be impossible, yet astronomers have developed ways to infer their number, drawing upon light, motion, and statistical patterns. Each star contributes to the galaxy's overall glow, from the faintest red dwarf flickering quietly in the background to massive radiant giants that illuminate nearby clouds of gas. And among this staggering multitude is our own sun, an unassuming star that nonetheless sustains an entire system of planets, comets, and asteroids. Contemplating the billions of stars encourages a perspective shift, a quiet realization that our individual existence, small and fleeting, is entwined with a vast, ongoing cosmic symphony. Even in our solitude, we are accompanied by countless stellar companions, each following its own path, each participating in a rhythm of creation and destruction that has persisted for eons. The Milky Way is both infinite in its scale and intimate in its connection to us, a paradox that invites both awe and reflection. The role of gas and dust in the galaxy. Here's something often overlooked. Between the stars lies a pervasive, almost invisible substance of gas and dust. Though it may seem unremarkable compared to bright stars, this interstellar medium is the lifeblood of the galaxy. It drifts gently through the spiral arms, filling the spaces between stars and serves as the raw material for future stellar generations. Dense clouds of gas collapse under gravity to form stars, while dust grains, tiny fragments of carbon, silicon, and ice, absorb and scatter light, shaping the patterns we see from Earth. In some regions, the interplay of gas and dust gives rise to nebulae that glow softly in the spectrum of visible light, painting the galaxy in ethereal blues, pinks, and greens. Without this quiet, pervasive medium, the Milky Way could not sustain the ongoing cycle of stellar birth, evolution, and death. It is in this interstellar fabric, largely unseen yet profoundly influential, that the galaxy maintains its vitality, weaving the threads of matter into new stars and new possibilities. Reflecting on this hidden component brings a sense of wonder. The universe's greatest transformations often occur in silence, away from the brilliance that draws the eye. Yet their impact resonates across billions of years and countless light-years of space. How stars are born in nebula. At first glance, nebula appear as delicate clouds, drifting serenely in the cosmos, their shapes soft and diffuse. But within these gentle veils of gas and dust, a remarkable process unfolds: the birth of stars. Gravity gathers the dispersed material into dense clumps, compressing gas until the pressure and temperature ignite nuclear fusion. A new star emerges, glowing steadily against the dark backdrop of space, sometimes alone, sometimes in clusters with its siblings. Surrounding disks of gas may gradually coalesce into planets, offering the possibility of future worlds. Some nebulae, like the Orion Nebula, radiate brilliant light as young stars energize the surrounding gas, casting a soft, otherworldly glow that can be seen from Earth with the aid of telescopes. This process, slow and imperceptible in human terms, is a miracle of transformation. Chaos giving birth to order, darkness birthing light, potential becoming reality. Watching these stellar nurseries through scientific instruments is like peering into the universe's womb, witnessing the continuation of life on a cosmic scale. Nebulae remind us that even in the vast emptiness of space, creation is constant, quiet, and breathtakingly beautiful. Stellar nurseries and their glow. Think about this. Some of the most beautiful sights in the night sky are the stellar nurseries, clouds of gas and dust glowing softly under the light of newborn stars. These regions, often called emission nebulae, are alive with energy, yet move at a pace almost impossible to perceive. The stars within radiate ultraviolet light, which excites the surrounding hydrogen gas, causing it to emit vivid reds and pinks that seem to pulse with life. In these nurseries, star formation is not uniform. Some pockets collapse quickly, giving birth to massive stars, while others remain quiescent, slowly accumulating material over millennia. Observing this gentle glow, one senses the galaxy's rhythm, the steady heartbeat of creation unfolding silently over cosmic time. These glowing clouds are more than picturesque. They are laboratories of the universe, where matter transforms, where light is born, and where the ongoing story of the Milky Way is written in subtle, radiant detail. The life cycle of a star. At first glance, a star may seem eternal, its brilliance a constant companion in the darkness. Yet each star lives a life of dramatic transformation, from the quiet gathering of material in a nebula to the roaring brilliance of its main sequence adulthood. Hydrogen fuses into helium in the core, producing energy that radiates outward, maintaining the star's delicate balance. Over millions or even billions of years, a star gradually evolves, expanding or contracting, shifting in temperature and luminosity. Some swell into red giants, shedding layers that drift into space, enriching the galaxy with the elements for future stars and planets. The life of a star is a testament to change, a meditation on impermanence and resilience. Even in death, stars leave a legacy, scattering the building blocks of worlds and nurturing the next generation of celestial bodies. In contemplating a star's cycle, we are invited to reflect on our own lives, brief yet meaningful flashes of light within a vast interconnected cosmos. What happens when stars die? Here's something humbling. The end of a star's life is neither silent nor insignificant. Depending on its mass, a star may collapse gently, forming a white dwarf, or erupt violently in a supernova, a brilliant explosion that outshines entire galaxies for a short time. These deaths scatter the star's material into space, seeding future generations of stars with heavier elements essential for planets, and ultimately, life. The quiet remnants like white dwarfs, neutron stars, or pulsars continue to influence the galaxy, their gravity shaping nearby orbits and sometimes emitting beams of radiation across vast distances. In death, stars continue to teach us about the interconnectedness of matter and energy. They remind us that endings are transformations, that what seems final often gives rise to new beginnings. Observing these processes from afar, we gain perspective on the intricate cycles that sustain the Milky Way, a silent testimony to nature's patience and continuity. Supernovae and galactic recycling. Imagine a single point in the sky suddenly becoming almost unbearably bright for a brief moment, a star announcing its death in a supernova. This cataclysmic event is a pivotal part of galactic ecology, recycling elements forged in stellar cores back into the interstellar medium. These elements, carbon, oxygen, iron, and more, become the seeds for new stars, planets, and potentially life itself. Supernovae also drive shockwaves through space, compressing nearby clouds of gas and triggering the birth of new stars. In a quiet sense, they are both destroyers and creators, illustrating the duality that permeates cosmic processes. Watching this cycle from a human perspective, one cannot help but feel a mix of awe and serenity, life and death, creation and collapse, all woven together in the continuous, intricate narrative of our galaxy. The glow of a supernova may fade in weeks, but its impact resonates for millions of years, a cosmic echo reminding us of the delicate balance and ceaseless motion that defines the Milky Way. Neutron stars and pulsars in the galaxy. At first glance, neutron stars appear almost paradoxical. Incredibly small, often no larger than a city, yet containing more mass than the Sun. They are the dense remnants of massive stars, compressed to extraordinary degrees by gravity. Some spin at dizzying speeds, emitting beams of radiation like cosmic lighthouses, which we detect as pulsars. These celestial beacons mark positions in the galaxy with remarkable precision, almost like signposts in the vast darkness. Despite their small size, neutron stars influence their surroundings profoundly, their gravity bending space, and sometimes capturing companion stars into orbital dances. Observing them reminds us that the universe thrives on extremes. Immense density, incredible speed, and delicate balance coexist in ways that defy ordinary imagination. In the quiet hum of a pulsar, we can sense the ongoing rhythm of the Milky Way, a subtle signal of the life and death of stars, and a testament to the astonishing diversity of celestial phenomena that inhabit our galactic home. The mystery of black holes. Think about this. At the heart of many galaxies lie regions where gravity becomes so intense that not even light can escape. These are black holes, enigmatic objects that challenge our understanding of space and time. Invisible to direct observation, their presence is revealed by the motion of nearby stars and the energetic radiation emitted as matter spirals inward. The Milky Way harbors one such giant at its center, a sentinel around which countless stars orbit in silent precision. Black holes are both destructive and fascinating, acting as cosmic engines that shape their surroundings. They remind us that the universe is full of extremes, places where the familiar rules of physics bend and twist, inviting curiosity and humility. In contemplating a black hole, we encounter the sublime, the intersection of mystery, power, and the limits of human knowledge. Sagittarius A, the black hole at the center. At first glance, the center of our galaxy seems like just another dense cluster of stars. Yet hidden within it lies Sagittarius A, a supermassive black hole millions of times more massive than our Sun. Its gravity dominates the motions of stars in the galactic core, orchestrating their intricate orbits over centuries. Despite its immense pull, we remain safely far away, observing it with sophisticated instruments that capture the subtle effects on nearby matter. Sagittarius A is a silent conductor of the Milky Way, shaping the central region and anchoring the galaxy's overall structure. Gazing at it, even in imagination, evokes both awe and a profound sense of cosmic perspective, a reminder that the universe contains forces and scales far beyond ordinary human experience. The dance of stars around the black hole. Here's something astonishing. Stars near Sagittarius A do not fall in. They orbit in intricate elliptical paths, some reaching astonishing speeds. Watching this dance through telescopes, astronomers can measure the black hole's mass and even test predictions of Einstein's general relativity. These stars, whirling in their cosmic ballet, demonstrate the interplay of gravity, momentum, and time on a scale both extreme and elegant. It is humbling to realize that while we sleep on a quiet planet far from the galactic center, these stars trace their paths in a choreography older than any human civilization. The dance continues largely unnoticed, a serene yet powerful testament to the invisible forces shaping our galaxy, and a reminder of the delicate balance that allows galaxies, stars, and planets to exist. Dark matter and the Milky Way's hidden mass. At first glance, the Milky Way's stars, gas, and dust may seem to account for all its mass. Yet observations reveal a profound secret. Most of the galaxy is invisible. Dark matter, an elusive substance we cannot see, dominates the gravitational landscape. It surrounds the galaxy, binding stars in their orbits and giving structure to spiral arms. Though mysterious, its effects are measurable, subtly shaping everything from star velocities to the motion of satellite galaxies. Dark matter is a quiet, pervasive presence, a reminder that what we perceive is only a fraction of reality. In contemplating this hidden mass, we encounter a humbling truth. Much of the universe is unknown, yet it shapes us and our cosmic home in ways we are only beginning to understand. The Milky Way is not just a luminous spectacle, it is a vast, intricate structure whose deepest foundations remain concealed, challenging our perception and sparking quiet wonder. The galactic halo that surrounds us. Think about the Milky Way as not just a flat disk, but a sphere extending far beyond the spiral arms. This is the galactic halo, a diffuse, ancient envelope of stars, globular clusters, and dark matter that reaches tens of thousands of light-years above and below the plane. The halo contains relics from the earliest stages of the galaxy's formation, including stars older than most in the disk, drifting slowly in their vast orbits. It is sparsely populated, almost ghostly in its emptiness. Yet its presence is essential, influencing the motion of stars and the overall stability of the galaxy. Looking out into the halo, one can almost sense the Milky Way's history written in quiet traces, the remnants of ancient mergers and cosmic collisions. It is a place of reflection, a reminder that the galaxy's story is not just what we see in bright arms and glowing nebulae, but also in the silent, lingering reaches that stretch into the darkness of space. Globular clusters, ancient star cities. At first glance, globular clusters appear as dense, spherical gatherings of stars, glittering like celestial jewels scattered across the galactic halo. These clusters are among the oldest structures in the Milky Way, containing stars that formed billions of years before our sun existed. Each cluster can contain hundreds of thousands, sometimes millions, of stars packed into a relatively small region of space, bound tightly by gravity. Observing them is like peering into a cosmic archive, glimpsing the earliest chapters of our galaxy's history. The stars within these clusters often move in elegant, elliptical orbits, creating a slow, harmonious dance that has persisted for eons. In their quiet brilliance, globular clusters serve as reminders of both endurance and the passage of time. They are star cities frozen in age, offering insight into the conditions of the early universe while inspiring awe at the scale and order that can emerge in the cosmos. Open clusters, families of young stars. Here's something remarkable. Unlike globular clusters, open clusters are loose, irregular groupings of young stars, often formed from the same molecular cloud. Their members share a common origin, a stellar family born together and drifting through space in a delicate gravitational embrace. Some open clusters contain only a few dozen stars, while others boast thousands, glowing softly in colors that reflect their temperature and age. Over millions of years, these stars slowly disperse, mingling with the galaxy at large, but for a brief cosmic moment, they shine as a coherent group. Observing an open cluster is like watching a family grow and mature, each star following its own path, yet connected by shared beginnings. They remind us that even in the vastness of space, relationships, origins, and connections matter, a quiet reflection of community on a cosmic scale. The spiral arms and their secrets. Think about the Milky Way's spiral arms as rivers of stars flowing through the galaxy, curving outward from the central bar in sweeping, elegant arcs. These arms are regions of heightened star formation, where gas and dust are compressed under gravity, giving birth to brilliant new stars. Some arms glow with young, hot stars, painting the galaxy in ethereal blues, while others contain older stars settled into quieter tones of amber. Spiral arms are also highways for matter, guiding the motion of stars, gas clouds, and cosmic dust, creating patterns that persist across hundreds of millions of years. Their structure is not static. Density waves ripple through the arms, influencing stellar orbits and the formation of new clusters. Contemplating the spiral arms is to witness the dynamic heartbeat of the galaxy, a slow pulse of creation and motion that shapes the Milky Way's identity while connecting its countless stars into a coherent, flowing tapestry. The Orion Arm, our local neighborhood. At first glance, our solar system might seem adrift in a sea of stars, but we inhabit a defined structure within the galaxy, the Orion Arm, sometimes called the Orion Spur. It is a smaller segment nestled between two major spiral arms, and it hosts the Sun, our planetary system, and many neighboring stars and nebulae. This region is rich with star-forming clouds, luminous nebulae, and young stellar clusters, offering a glimpse into the ongoing processes that shape the Milky Way. From here, the broader spiral structure of the galaxy stretches outward, a reminder of our relative place in the cosmic ocean. Thinking of the Orion Arm as our celestial neighborhood helps us grasp the scale and complexity of the galaxy. Our sun's path through this region is a quiet, almost imperceptible journey, yet it carries us past ancient stars, nascent stellar nurseries, and the subtle gravitational contours that define the Milky Way's grand design. The sun's place in the galaxy. Here's something profoundly grounding. The sun, the star that sustains life on Earth, is but one of hundreds of billions in the Milky Way, quietly tracing its orbit around the galactic center. Positioned roughly 27,000 light-years from the core, the sun sits in a relatively calm region of the Orion Arm, away from the most tumultuous gravitational forces near the center. Its motion is steady, a gentle glide of about 828,000 kilometers per hour, completing a full orbit roughly every 225–250 million years. In cosmic terms, our sun is ordinary, yet its location and stability have allowed life on Earth to flourish. Reflecting on this is both humbling and reassuring. We are intimately tied to a single star in a vast galaxy, yet the conditions that surround it are precise enough to nurture complexity, creativity, and consciousness. Our solar system's place in the Milky Way is a delicate balance between motion and stillness, a reminder of the interconnectedness and subtle harmony that permeates the cosmos. How long it takes the sun to orbit the center. At first glance, the sun's journey through the Milky Way seems imperceptible, a gentle drift across the cosmic stage, yet in reality, it traces a vast elliptical path around the galactic center, moving at roughly 828,000 kilometers per hour. Even at this incredible speed, it takes the sun approximately 225 to 250 million years to complete a single orbit, a period sometimes called a galactic year. Consider this. When the sun last occupied the position it holds today, the earliest multicellular life was just beginning to emerge on Earth. Each orbit is a quiet rhythm, a cosmic metronome marking the passage of time across eons. The sun's path threads through spiral arms, passing regions of star formation and interstellar clouds, carrying its retinue of planets along in a silent, unbroken journey. Contemplating this orbit is a humbling reminder of scale, motion, and the patient persistence of the universe. The sun's voyage connects our present to both the deep past and a distant future, a continuous story written across light years and centuries. Why stars move at unexpected speeds? Here's something that challenges intuition. Not all stars move as neatly as we might expect. Observations show that many stars travel faster or slower than simple models of galactic rotation would predict. This apparent irregularity reveals the hidden structure of the Milky Way, including the influence of dark matter, gravitational interactions, and past collisions with smaller galaxies. Some stars have been flung outward from close encounters with massive objects, while others drift along resonant paths shaped by spiral density waves. Even our sun experiences subtle variations in its motion due to these factors. Watching stars glide, twist, and sometimes race through the galaxy is like observing a river whose currents are guided by unseen channels. Each deviation from the expected path carries a story of cosmic interaction, a record of the forces that sculpt the Milky Way over billions of years. In this we find both mystery and poetry, a dynamic, living galaxy where nothing is truly stationary. The galactic bar at the core. At first glance, the Milky Way may appear as a simple spiral, yet at its very heart lies a striking structure. The galactic bar, stretching thousands of light years across the central region. This elongated formation funnels stars and interstellar gas toward the dense core, influencing the motion of nearby spiral arms. It acts almost like a cosmic engine, driving the dynamics of the central galaxy while shaping star formation and the distribution of matter. The bar rotates slowly, taking tens of millions of years for a single revolution, and its presence affects the orbits of countless stars, including those far beyond the core. Contemplating this hidden structure reveals the complexity beneath the galaxy's serene appearance, reminding us that even in apparent stillness, immense forces shape and guide the motions of billions of stars. It is a testament to the quiet sophistication of cosmic architecture, where subtle forms dictate motion across unimaginable scales. Interstellar gas and cosmic dust clouds. Think about the spaces between stars, not empty voids, but realms filled with interstellar gas and cosmic dust, weaving an invisible web across the galaxy. These clouds are the seeds of creation, harboring the potential for new stars, planets, and sometimes entire star systems. They drift along galactic currents, interacting with radiation, magnetic fields, and shock waves from nearby supernovae. Some clouds glow softly under the light of young stars, painting the galaxy with subtle, ghostly colors visible in long-exposure images. Others remain dark, opaque and silent, obscuring distant stars while quietly shaping the future. Observing these clouds, one senses the patience of cosmic processes, immense masses of matter, moving and coalescing over millions of years, imperceptibly sculpting the galaxy's evolution. They remind us that the Milky Way is alive with slow, deliberate change, a vast system where even unseen matter plays a crucial, ongoing role in the cycle of creation and transformation. The chemistry of the Milky Way. At first glance, the Milky Way might seem like a simple scattering of stars. Yet each region, star and cloud is a laboratory of chemistry on a grand scale. Hydrogen and helium dominate, remnants of the early universe, but heavier elements, carbon, oxygen, iron, and beyond have been forged in the hearts of stars and dispersed through supernovae. These elements mingle in interstellar clouds, enriching the galaxy with the material needed for planets, oceans, and perhaps life itself. Observing this chemical tapestry is like reading a story written in atoms, tracing the history of matter from the Big Bang to our own existence. In this, the galaxy is both a teacher and a poet, demonstrating the cycles of transformation that govern all matter, from the simplest hydrogen atom to the complex compounds essential for life. The Milky Way's chemistry reminds us that creation is continuous, a gentle, ongoing symphony of elements moving, reacting, and recombining across time and space. Heavy elements forged in stars. At first glance, stars might seem like simple points of light, but within their cores, a quiet alchemy is taking place. Through nuclear fusion, lighter elements like hydrogen and helium are fused into heavier ones. Carbon, oxygen, silicon, and iron. Each new element a building block for planets, oceans, and even life. When massive stars reach the end of their lives, they often explode as supernovae, scattering these newly forged elements into the galaxy. This cosmic recycling enriches interstellar gas clouds, seeding future generations of stars with the material necessary for complexity. In this way, every atom of iron in our blood, every oxygen molecule we breathe, was once part of a distant star. Contemplating this process evokes a sense of connection, a quiet awareness that we are intrinsically linked to the galaxy's ongoing cycle of creation, birth, and transformation. Stars, in their brilliance and eventual demise, write the chemical story of the Milky Way, a story that continues to unfold in every corner of space. How the Milky Way feeds on smaller galaxies. Here's something extraordinary. The Milky Way is not isolated, but part of a cosmic ecosystem where galaxies interact, merge, and consume one another. Over billions of years, our galaxy has drawn in smaller companions, their stars and gas streams absorbed into the galactic disk and halo. These minor mergers leave subtle signatures, streams of stars moving in unusual orbits, twisted spiral arms, and enriched regions of interstellar gas. This feeding process is slow, often taking millions of years, yet it plays a critical role in shaping the galaxy's structure, composition, and star formation. Observing the Milky Way in this context reminds us that galaxies are dynamic, evolving entities. The quiet assimilation of smaller galaxies demonstrates that even seemingly stable systems are constantly reshaped by gravity and time, a gentle yet inexorable process that continues to define the Milky Way today. The Cannibal Galaxy, Sagittarius Dwarf. At first glance, the Sagittarius Dwarf spheroidal galaxy seems small and unremarkable, yet its interaction with the Milky Way tells a dramatic story. This compact galaxy is currently being torn apart by our galaxy's gravitational pull, leaving behind streams of stars that arc gracefully across the galactic halo. Though invisible to the naked eye, these stellar streams are detectable by careful observation, tracing the path of a galaxy, slowly dissolving into the larger system. The Sagittarius Dwarf reminds us that the Milky Way's growth is ongoing, built not only from its own star formation, but also through the quiet assimilation of smaller neighbors. Its slow demise is both a process of destruction and creation, contributing to the enrichment of the Milky Way with stars, gas, and perhaps even dark matter. In the faint traces of its stars, we see the echoes of cosmic collisions, a meditation on impermanence on the grandest of scales, streams of stars pulled into the Milky Way. Think about this. Scattered across the galactic halo are long, delicate streams of stars, remnants of galaxies and star clusters gradually absorbed into the Milky Way. These stellar rivers stretch across tens of thousands of light years, following paths dictated by gravity and the galaxy's rotation. Each stream is a memory of a past encounter, a record of a smaller system surrendering to the greater mass of the Milky Way. Observing them is like reading an ancient history book written in starlight, each star a word, each stream a sentence, in a tale spanning billions of years. These streams are not chaotic. They follow precise orbits, reflecting the invisible scaffolding of dark matter that guides their motion. In contemplating them, we gain perspective on the Milky Way's quiet evolution, a process of gentle absorption and transformation, where the past continually shapes the present, and the galaxy's structure emerges from both creation and assimilation. Andromeda, the future collision partner. Here's a cosmic thought that is both sobering and awe-inspiring. The Milky Way and the Andromeda Galaxy are slowly moving toward each other, destined to collide in roughly 4 billion years. Though the idea of two massive galaxies merging might suggest chaos, the reality will be a slow, graceful dance of gravity, taking hundreds of millions of years to complete. Stars within each galaxy are unlikely to collide directly due to the vast distances between them, but their orbits will be dramatically altered. Gas clouds will compress, triggering waves of star formation, and the two galaxies may eventually settle into a single enormous elliptical galaxy. Imagining this future collision offers a glimpse into the long-term evolution of galaxies, a reminder that the Milky Way is not static, but a participant in the grand, ongoing narrative of the universe. It is a humbling and poetic thought that our cosmic home will one day merge with a distant neighbor in a slow, inevitable embrace. What a galactic collision looks like. At first glance, imagining two galaxies colliding might conjure images of violent, chaotic explosions, yet the reality is far more subtle and elegant. On cosmic timescales, such collisions unfold slowly, over hundreds of millions of years, like a slow-motion dance. Stars themselves rarely crash into one another due to the vast distances separating them, but gas clouds interact, compress, and ignite waves of new star formation. Spiral arms twist and stretch, tidal tails of stars unfurling, like celestial ribbons into space. From a distance, the merging galaxies appear as luminous, distorted shapes, their combined glow a testament to the dynamic and ever-changing nature of the universe. These collisions are both destructive and creative, reshaping the galaxies involved, sparking bursts of stellar birth, and redistributing matter. In witnessing a galactic collision, even in imagination, we glimpse the grand cycles of transformation that govern the cosmos. Slow, inevitable, and profoundly beautiful. How stars survive galactic mergers. Think about this. Despite the seeming chaos of a galactic collision, most stars survive intact, carrying their planetary systems with them through the gravitational turbulence. Their enormous separations make direct collisions rare, yet their orbits are subtly altered, creating new patterns of motion that will endure for billions of years. Some stars may be flung into elongated, looping trajectories, wandering through the galaxy as cosmic nomads. Others will settle into newly formed elliptical structures, part of a harmonious equilibrium born from the encounter. Observing how stars adapt to these cosmic upheavals is a reminder of resilience on an unimaginable scale. Life continues, motion persists, and matter endures, reshaped but not destroyed. In these patterns, the galaxy teaches us about balance, adaptation, and the quiet perseverance of structures across time, where even the most dramatic events yield enduring order and beauty. The fate of the Milky Way and Andromeda. Here's something both humbling and inspiring. In 4 billion years, the Milky Way and Andromeda will merge, forming a new colossal galaxy. The process is slow and deliberate, with gravity orchestrating a complex interplay of stars, gas, and dark matter. Spiral arms will twist, new stars will ignite, and the central supermassive black holes may eventually merge, releasing bursts of energy into the surrounding space. Over time, the resulting galaxy may take on an elliptical form, a quieter, more settled structure compared to the swirling spirals we see today. This eventual fate reminds us that the universe is not static. Even seemingly stable structures are transient, constantly evolving under the influence of gravity and time. The Milky Way's current form is temporary, a fleeting snapshot in a story that spans billions of years. And contemplating this long-term future evokes both wonder and a sense of cosmic humility. The larger local group of galaxies. At first glance, the Milky Way might seem like an isolated island in space, but it is part of a larger family known as the local group. This collection of more than 50 galaxies includes the massive Andromeda and Triangulum galaxies, along with countless smaller satellite galaxies orbiting them. Within this group, gravitational interactions shape the motions, structures, and evolution of each member. Satellite galaxies are gradually absorbed, streams of stars trace past encounters, and the motions of these galaxies reveal the underlying presence of dark matter. The local group is a reminder that the Milky Way is not an island unto itself. It is part of a dynamic, interconnected system, a small but significant node in the cosmic web. Observing the group provides perspective on scale, relationship, and the subtle gravitational threads that bind galaxies across millions of light years, silently choreographing the evolution of these immense structures. Where the Milky Way sits in the cosmic web. Think about this. Beyond the local group, the Milky Way is a single strand in a vast, intricate cosmic web, a filamentary network of galaxies, gas, and dark matter stretching across the observable universe. This web dictates the large-scale structure of the cosmos, guiding the motion of galaxies and shaping the distribution of matter. Our galaxy resides on the outskirts of one of these filaments, tracing a path through an interconnected network that links countless other galaxies, each with their own stars, planets, and histories. In this context, the Milky Way is both immense and minuscule, a familiar home within a structure of unimaginable scale. Contemplating our place in the cosmic web evokes a quiet humility. The universe is ordered and connected, yet overwhelmingly vast. Our galaxy, with all its stars and worlds, is a tiny luminous thread woven into a tapestry of unimaginable breadth and depth, reminding us that even the smallest structures participate in the grand cosmic story. The influence of dark energy on the galaxy. At first glance, dark energy might seem distant and abstract, yet its influence permeates the Milky Way and the cosmos beyond. This mysterious force, driving the accelerated expansion of the universe, subtly shapes the galaxy's future by affecting the space between galaxies. While its effects on the Milky Way itself are imperceptible on human timescales, dark energy governs the broader cosmic environment, influencing how galaxies cluster, drift, and eventually interact. Thinking about dark energy evokes a sense of humility. Forces we cannot see still guide the evolution of everything we know. In this quiet, invisible influence, we glimpse the profound interconnectedness of the cosmos, where even emptiness carries power, shaping the destiny of stars, clusters, and entire galaxies over billions of years. The Milky Way, in its serene rotation, is both a participant in and a witness to this invisible cosmic tide. Gamma-ray bursts in the galaxy's past. Here's something astonishing. The Milky Way has experienced gamma-ray bursts, brief yet extraordinarily energetic explosions that can outshine entire galaxies. These bursts often result from the death of massive stars or collisions between neutron stars, releasing intense radiation across the galaxy. Though rare, they are capable of influencing surrounding stellar systems, perhaps even affecting planetary atmospheres if close enough. Observing their remnants, astronomers piece together a history of energetic events that punctuate the galaxy's long, slow evolution. Gamma-ray bursts remind us of the Milky Way's dynamic nature, quiet most of the time, yet capable of sudden, profound displays of power. In contemplating these bursts, we sense both the fragility and resilience of cosmic structures, a reminder that creation and destruction are intertwined in the ongoing rhythm of the universe. The oldest stars we have found, think about this. Scattered throughout the Milky Way are stars that formed almost as soon as the universe itself allowed. These ancient stars, often found in the halo or in globular clusters, have lived quietly for more than 13 billion years, preserving chemical signatures from the earliest epochs of star formation. They are cosmic time capsules, telling us about the conditions of the primordial universe and the processes that led to the formation of galaxies. Observing them, we are reminded of the longevity and resilience of stars, and of the continuity that links our present to the earliest chapters of cosmic history. In their quiet persistence, these ancient stars offer a form of cosmic memory, a connection to a universe vastly older than humanity, yet intimately linked to the atoms that make up our world and ourselves. Halo stars, older than the galaxy itself. At first glance, it seems impossible. Stars older than the galaxy they now inhabit. Yet the galactic halo contains stellar relics that predate much of the Milky Way structure. Remnants of smaller galaxies and clusters absorbed during the galaxy's early growth. These stars drift slowly through the halo, moving in wide, elliptical orbits that testify to their ancient origins. They are witnesses to mergers, gravitational interactions, and the gradual assembly of the Milky Way over billions of years. Contemplating these halo stars evokes a profound sense of continuity. The galaxy we see today is built upon layers of cosmic history, each star a marker of events long past. In this quiet halo, we can trace the Milky Way's lineage, understanding that even our familiar home is the result of countless mergers and interactions over incomprehensible timescales. The population of different star types. Here's something quietly astonishing. The Milky Way is home to a vast diversity of stars, from massive, short-lived blue giants to humble red dwarfs burning steadily for tens of billions of years. Each type of star contributes differently to the galaxy's luminosity, chemical enrichment, and dynamics. Giants and supergiants illuminate nebulae, seeding the interstellar medium with heavier elements, while smaller stars dominate in number, providing stability and continuity across time. Variable stars pulse rhythmically. Pulsars emit precise beams of radiation, and exotic objects like neutron stars and white dwarfs remind us of the galaxy's extremes. Observing this population offers insight into the Milky Way's complex ecosystem, where each star, no matter its size or age, plays a role in the ongoing cycle of birth, life, and eventual death. This stellar diversity is a reflection of cosmic balance and creativity, a meditation on the myriad ways the universe manifests light and matter across time and space. Brown dwarfs, failed stars in the shadows. At first glance, the galaxy is dominated by luminous stars, yet scattered among them are brown dwarfs, objects that straddle the line between planet and star. These failed stars formed like stars but lacked sufficient mass to ignite sustained hydrogen fusion in their cores. They emit faint heat and infrared light, often invisible to the naked eye, drifting silently through the Milky Way. Despite their subtle presence, brown dwarfs are important, providing clues about star formation processes and the lower limits of stellar mass. They remind us that the galaxy is more than what is bright and easily observed. It contains hidden layers of matter and energy, quietly shaping its evolution. In contemplating these elusive objects, one gains a sense of humility. Not all cosmic actors are radiant, yet each plays a role in the quiet, intricate choreography of the galaxy. Their existence invites reflection on subtlety and resilience, showing that even what seems incomplete or dim can carry significance across eons. Rogue stars escaping the galaxy. Here's something extraordinary. Some stars are not bound by the Milky Way's gravity at all. Rogue stars, ejected by gravitational interactions or cataclysmic events, drift through intergalactic space, solitary travelers moving at astonishing speeds. Their journeys are perilous and lonely, often lasting billions of years across the emptiness between galaxies. Yet they carry with them traces of the environments from which they were born, bearing the chemical fingerprints of the regions and clusters they once inhabited. Observing these nomadic stars reminds us of the dynamism and unpredictability of the galaxy, where even massive luminous objects can be cast adrift. In their wandering, rogue stars reflect the interplay of chance and gravity on cosmic scales, offering a poetic meditation on freedom, displacement, and the immense distances that shape our universe. They are reminders that even in the vast interconnected web of the Milky Way, individual trajectories can break free, exploring realms we can barely imagine, the fastest stars ever detected. Think about this. Some stars move so rapidly that they are capable of escaping the Milky Way entirely. Known as hypervelocity stars, they can achieve speeds exceeding 1,000,000 kilometers per hour, often propelled by interactions with the supermassive black hole at the galaxy's center or through gravitational encounters with other massive stars. These stellar sprinters are rare and fleeting, yet their discovery tells us about the energetic extremes that exist within our galaxy. Observing their motion provides insight into gravitational forces, galactic structure, and the dynamic processes occurring in dense stellar environments. Hypervelocity stars remind us that even the Milky Way, vast as it is, cannot contain all its constituents indefinitely. The universe is in constant motion, and on scales of millions or billions of years, no path is fixed. These stars trace the tension between gravitational binding and freedom, illustrating the delicate, invisible forces that govern motion on galactic scales. Exoplanets around Milky Way stars. At first glance, we might think of the galaxy in terms of stars alone, but many of these stars host planetary systems, each a miniature solar system with its own potential for complexity. Exoplanets, worlds orbiting stars beyond the Sun, are now known to exist in staggering numbers throughout the Milky Way. Some are gas giants, swirling behemoths like Jupiter, while others are rocky, Earth-sized planets, quietly circling their suns in orbits that may allow for liquid water. Each discovery deepens our understanding of the galaxy's potential to harbor life and hints at the diversity of worlds that may exist. Observing these distant planets is like peering into countless stories of creation, each system a reflection of the same cosmic processes that formed our own solar system. In this quiet proliferation of worlds, we find both wonder and hope, imagining the endless possibilities that exist among the billions of stars scattered across the galaxy. The search for habitable worlds. Here's something quietly inspiring. Astronomers are actively searching for planets that could support life, worlds where the conditions are just right for liquid water, a stable climate, and complex chemistry. These habitable zone planets are often discovered around stars similar to the Sun, yet they can also orbit dimmer or more variable stars, expanding the range of possibilities. Each candidate world sparks reflection on the rarity and fragility of life, reminding us of the delicate balance required for habitability. The search itself is an exploration of both the cosmos and our own understanding of life's requirements, blending science with curiosity, patience, and imagination. By studying these distant worlds, we learn not only about the Milky Way's potential to harbor life, but also about the extraordinary conditions that allow our own existence. In this search, the galaxy becomes a vast, unfolding laboratory, a quiet canvas of possibility stretching across light years, inviting contemplation and wonder. How common Earth-like planets might be. At first glance, Earth might seem singular, a fragile oasis in the vastness of space. Yet astronomers have discovered thousands of exoplanets, some residing in the so-called habitable zones of their stars, where temperatures allow for liquid water. Statistical studies suggest that planets like Earth may be surprisingly common, orbiting a significant fraction of the Milky Way stars. Each discovery invites reflection on our place in the cosmos, raising questions about the uniqueness of life and the processes that lead to habitable environments. Even if we cannot see these worlds directly, understanding their potential abundance encourages a sense of connection to a galaxy teeming with possibilities. In imagining these countless Earth-like planets, we are reminded that the Milky Way is not just a backdrop for human life, but a dynamic system full of worlds waiting to reveal their secrets. The search for extraterrestrial life. Here's something quietly profound. For decades, scientists have searched for signs of life beyond our planet, listening for faint signals, analyzing planetary atmospheres, and studying extreme environments in our own solar system for clues. The Milky Way, with its billions of stars and myriad planets, offers vast potential habitats. Life, if it exists elsewhere, may be unimaginably different from our own, thriving in conditions we scarcely comprehend. This search is both scientific and philosophical, a meditation on the rarity and resilience of life. Every discovery, from a water-rich moon to an exoplanet in the habitable zone, brings hope and wonder, reminding us that the galaxy is full of mystery and potential. The quest for extraterrestrial life transforms the Milky Way from a distant spectacle into a living, interactive system, one in which humanity is both observer and participant in a universe of untold possibilities. The Fermi paradox in a galactic context. At first glance, it seems perplexing. With billions of stars and potentially habitable planets, why have we not detected signs of intelligent life elsewhere? This question, known as the Fermi paradox, invites reflection on the vast scales, the limitations of observation, and the rarity of certain conditions necessary for life to develop advanced intelligence. Perhaps civilizations arise but self-destruct, remain hidden, or communicate in ways we cannot detect. Contemplating this paradox in the context of the Milky Way deepens our appreciation for the galaxy's immensity and the subtle probabilities that govern life. It reminds us of our own preciousness, the fleeting and fragile nature of intelligence, and the cosmic silence that stretches across light years. The Fermi paradox is not a failure of imagination, but an invitation to wonder, a quiet meditation on the profound mysteries still awaiting us among the stars. Why signals don't reach across the galaxy easily? Think about this. Even if other civilizations exist within the Milky Way, communicating across its vast expanse is extraordinarily challenging. Light and radio waves, traveling at immense speeds, still require tens of thousands of years to cross the galaxy's diameter. Signals dissipate, get absorbed, or become lost in cosmic noise. Stars, dust, and magnetic fields further complicate transmission. In such a vast system, even deliberate attempts at communication may never intersect, leaving civilizations effectively isolated. This reality highlights both the galaxy's scale and the subtle barriers that govern interactions across space. It encourages patience, humility, and reflection on the limits of observation. Each signal we send or hope to detect is part of a quiet dialogue across time and distance, a testament to the vastness of the Milky Way and the patience required to comprehend it fully. The vast silence of interstellar space. At first glance, the space between stars seems empty, a void devoid of activity. Yet even in this silence, there is structure, motion, and energy. Magnetic fields, cosmic rays, and interstellar gas drift unseen, shaping the galaxy's evolution. This quiet emptiness accentuates the brilliance of stars and the fragile light of planets. In contemplating this silence, one senses the profound calm of the cosmos, a stillness that stretches across light years and billions of years of history. The vast distances between stars create both isolation and perspective, a reminder of scale and the patience of cosmic processes. In this silence, we find space for reflection, a sense of the Milky Way's majesty, and an understanding of how delicate and rare our own conditions truly are. Even the emptiest regions of the galaxy hold lessons about resilience, scale, and the quiet persistence of matter and energy in the universe. Cosmic rays moving through the Milky Way. At first glance, space seems silent, yet a steady drizzle of high-energy particles, cosmic rays, permeates the Milky Way. These particles, accelerated by supernova explosions, pulsars, and other energetic events, travel at nearly the speed of light, weaving through the galaxy in invisible streams. As they pass through interstellar gas and magnetic fields, they ionize atoms, subtly shaping the chemistry of molecular clouds. Though imperceptible to our senses, cosmic rays are a constant presence, reminders of the energy and dynamism underlying the Milky Way's serene appearance. They travel across vast distances, linking the birth and death of stars, the remnants of supernovae, and even our solar system. In this quiet flow, one senses the interconnectedness of all things. Particles born in violent stellar events, far away, become part of a cosmic tapestry, a silent reminder that the galaxy is alive with motion, energy, and hidden interactions we are only beginning to understand. The magnetic field of the galaxy. Here's something subtle yet profound. The Milky Way is threaded with an invisible magnetic field, guiding charged particles, shaping gas clouds, and influencing star formation. This magnetic presence extends across the spiral arms and halo, weaving a delicate web that subtly organizes the motions of matter. Though it cannot be seen directly, its effects are measurable, from the orientation of dust grains to the behavior of cosmic rays and the dynamics of interstellar gas. The galactic magnetic field is both protective and constraining, a quiet influence that governs processes over millions of years. In contemplating it, one is reminded that much of the universe's structure is invisible, yet profoundly consequential. Like an unseen hand, it shapes the rhythms and patterns of the galaxy, an elegant reminder that the forces underlying cosmic order often operate quietly, beyond the reach of our senses, yet always present. The radio signals from pulsars. Think about this. Scattered throughout the Milky Way are pulsars, rapidly spinning neutron stars, emitting beams of radio waves like precise cosmic lighthouses. These signals sweep across space at regular intervals, sometimes milliseconds apart, offering astronomers natural clocks of astonishing precision. Pulsars trace the endpoints of stellar evolution, remnants of massive stars whose cores collapsed under immense gravity. Observing their radio signals allows us to probe the galaxy's structure, measure distances, and even detect gravitational waves indirectly. There is something meditative in the regularity of these pulses, a rhythm echoing across thousands of light years, a gentle beat marking the passage of cosmic time. In the quiet sweep of a pulsar's signal, we sense both the violence of stellar death and the serene persistence of order, a cosmic heartbeat linking distant regions of the Milky Way in a subtle, almost poetic network of energy and motion. What we see in infrared light. At first glance, the Milky Way presents itself as a glowing band of stars across the night sky, yet much of its structure is hidden behind clouds of gas and dust. Infrared observations allow us to peer through this veil, revealing star-forming regions, the central bar, and cooler stars invisible to visible light telescopes. Infrared light uncovers the galaxy's hidden skeleton, mapping its spiral arms, interstellar clouds, and nebulae in rich glowing detail. Through this window, we discover the quiet creativity of the cosmos, clouds collapsing into stars, clusters forming, and new light emerging from obscured corners. Infrared astronomy transforms the Milky Way from a familiar band into a three-dimensional landscape, a galaxy alive with processes otherwise invisible. In this gentle glow, we perceive the rhythms of creation and transformation, gaining insight into the hidden mechanisms that sustain the galaxy's luminous life. The X-ray glow of the galactic center. Here's something both dramatic and subtle. The center of the Milky Way emits a soft, diffuse glow in X-rays, a signature of high-energy phenomena occurring near the supermassive black hole and dense stellar regions. Hot gas, accelerated particles, and remnants of supernovae all contribute to this radiation, painting a portrait of a core both active and complex. Observing the X-ray glow reveals interactions otherwise invisible in optical or infrared light, from material falling toward the black hole to the energetic aftermath of stellar deaths. It is a region of extremes, yet it pulses with quiet consistency, a heartbeat at the galaxy's core. Contemplating this glow reminds us that even in darkness, energy flows, transformations occur, and the galaxy maintains its vitality. The X-ray universe offers a perspective beyond our senses, illuminating the unseen processes that shape not only the central regions but influence the galaxy as a whole. The Milky Way and gamma rays. At first glance, the Milky Way may appear as a soft, glowing ribbon of stars across the night sky. Yet when observed in gamma rays, an entirely different layer of reality emerges. Gamma rays reveal the most energetic events in the galaxy, the remnants of supernovae, jets from pulsars, and high-energy interactions near the supermassive black hole at the center. These rays, invisible to our eyes, pierce through dust and gas, tracing cosmic processes that operate at scales and energies beyond ordinary comprehension. Observing them is like hearing a secret heartbeat of the Milky Way, a rhythmic reminder of violent yet organized activity that sustains the galactic ecosystem. These emissions provide insight into particle acceleration, cosmic ray production, and the fundamental physics governing extreme environments. Contemplating the galaxy in gamma rays, one realizes that even the most tranquil appearance belies immense forces at work, a reminder of the hidden dynamism that permeates every corner of the Milky Way. The galaxy, in gamma light, is alive with energy, constant transformation, and a sublime reminder of the universe's hidden complexities. The story, think about this. Long before telescopes or sophisticated instruments, humans gazed at the Milky Way, wondering about its nature. Ancient civilizations, from the Babylonians to the Greeks and beyond, attempted to chart the stars, developing myths, calendars, and rudimentary maps. These early astronomers noticed patterns, seasonal shifts, and the faint luminous band stretching across the sky, speculating on its composition and significance. They could not have imagined the galaxy's full scale, its billions of stars, or its spiral structure, yet their observations laid the foundation for modern astrophysics. Their curiosity reflects an enduring human impulse to understand our place in the cosmos. Even without precise instruments, these observers connected with the galaxy in a profoundly intuitive way, mapping its rhythms and patterns and contemplating its immensity. Their efforts remind us that knowledge grows through patience, observation, and imagination, and that our fascination with the Milky Way is as old as civilization itself. In their quiet wonder, the earliest astronomers captured a sense of the sublime, a reverence for a universe far larger than themselves, mapping the galaxy in modern times. Here's something remarkable. Today, astronomers map the Milky Way with exquisite precision, using radio waves, infrared observations, and stellar parallax to chart its spiral arms, star clusters, and central bar. Surveys like the Sloan Digital Sky Survey and missions like Gaia have transformed our understanding, revealing the positions, motions, and even chemical compositions of billions of stars. Unlike the mythic or speculative observations of the past, modern mapping combines technology, mathematics, and careful patience, transforming the galaxy from an abstract concept into a detailed three-dimensional structure. These maps uncover hidden streams of stars, remnants of dwarf galaxies, and subtle distortions in the spiral arms. They are a testament to humanity's ability to reach beyond the immediate senses, translating faint signals from light years away into coherent knowledge. In these maps, we see the Milky Way as both familiar and alien, a vast, ordered system with secrets yet to be revealed, reminding us that exploration is a journey of both discovery and reflection, and that even a galaxy billions of years old still invites curiosity and wonder. The Gaia mission and the Milky Way's secrets. At first glance, Gaia may seem like just another satellite in orbit, yet its mission has profoundly reshaped our understanding of the galaxy. Launched to chart the positions, distances, and motions of over 1 billion stars, Gaia provides data of unprecedented accuracy, revealing the three-dimensional structure and dynamic evolution of the Milky Way. Through Gaia, astronomers trace stellar streams, detect subtle warps in the galactic disk, and uncover evidence of past mergers with smaller galaxies. Its precise measurements allow us to understand how the galaxy rotates, how stars orbit the center, and how dark matter influences motion on vast scales. Gaia transforms the Milky Way from a distant, abstract concept into a tangible, living system whose history and future can be traced with remarkable clarity. Observing its data is like seeing the galaxy through a new sense, one that allows us to perceive the invisible currents shaping stellar motion, chemical enrichment, and the ongoing evolution of our cosmic home. Gaia reminds us that even in a galaxy billions of years old, there are still secrets to uncover, and that human ingenuity can reveal them with patience, persistence, and quiet awe. What we still don't know about our galaxy. Think about this. Despite centuries of observation and decades of sophisticated measurement, the Milky Way remains full of mystery. We do not yet fully understand the exact distribution of dark matter, the detailed mechanisms of spiral arm formation, or the behavior of the supermassive black hole over cosmic time. Questions about the formation and evolution of the galactic halo, the fate of satellite galaxies, and the abundance of habitable worlds remain largely open. Even with detailed surveys like Gaia, the sheer scale, complexity, and dynamic nature of the galaxy ensure that each answer leads to new questions. This uncertainty is not a limitation, but a source of wonder, a reminder that the universe is vast, layered, and full of subtle processes that challenge human understanding. In contemplating what remains unknown, we are invited to embrace curiosity, to marvel at the Milky Way's intricacies, and to appreciate the beauty of a galaxy that is simultaneously known and mysterious, familiar and endlessly surprising. The unknown parts of the galaxy are as vital as the luminous stars themselves, providing space for imagination, inquiry, and the patient pursuit of knowledge. The question of the galaxy's true size. At first glance, the Milky Way might appear as a simple band of stars stretching across the sky. Yet determining its true size is a complex challenge. Our perspective from within the galaxy obscures its outer edges, leaving astronomers to piece together its dimensions using the motions of stars, the distribution of gas, and the faint traces of satellite galaxies. Estimates suggest a diameter of roughly 100,000 to 200,000 light-years. Yet the outer halo of dark matter could extend far beyond, reaching hundreds of thousands of light-years into space. Contemplating this scale evokes both wonder and humility. The Milky Way is not merely a backdrop for the solar system, but a vast, intricate system of matter, energy, and history. Each measurement is a glimpse into its enormity. Yet every answer raises new questions about its boundaries, structure, and hidden contents. In considering the true size of our galaxy, we confront the limits of perception, the challenge of mapping from within, and the awe-inspiring immensity of the cosmos that surrounds us. How far the halo really extends. Here's something quietly profound. The halo of the Milky Way, that diffuse, nearly invisible envelope of stars, gas, and dark matter, stretches far beyond the luminous spiral arms. Observations of globular clusters, stellar streams, and satellite galaxies suggest that this halo could extend more than 300,000 light-years from the galactic center. Within this halo reside ancient stars, relics from past mergers, and dark matter that dominates the galaxy's mass. Though faint and elusive, the halo is essential to the Milky Way's structure, providing gravitational support for the disk and influencing the orbits of stars and smaller galaxies. Its vast, sparse reaches evoke a sense of cosmic quietude, a reminder that even seemingly empty space is filled with history and matter. The halo's subtle presence teaches us patience and perspective. The galaxy is more than its bright center and spiral arms, a system that extends invisibly, yet profoundly, into the surrounding darkness. The future evolution of the Milky Way. Think about this. The Milky Way is not static, but a living system evolving over billions of years. Stars form, live, and die, enriching the galaxy with heavier elements, while smaller galaxies are absorbed, and dark matter subtly shapes motion. Looking forward, the Milky Way will continue to interact with its neighbors, most notably Andromeda, culminating in a collision that will merge the two galaxies into a massive elliptical galaxy. Over even longer timescales, star formation will slow as gas is consumed, and the galaxy will gradually settle into a quieter state. Contemplating this evolution highlights the transient nature of even seemingly eternal structures and reminds us that the cosmos is a continuous cycle of creation, transformation, and eventual quietude. The Milky Way's future is both inevitable and beautiful, a slow, graceful dance of matter and energy that will continue long after humanity has ceased to observe it. The final stars that will shine. At first glance, stars may seem eternal, yet each has a finite life, a luminous span bounded by mass, fuel, and nuclear processes. In the far future, only long-lived, low-mass stars, red dwarfs, will remain, burning quietly for trillions of years, outlasting even the brightest giants that flare and fade in mere millions of years. These final stars will continue to light the Milky Way's remnants, casting a gentle glow across a galaxy gradually emptied of gas and dynamic motion. Observing this distant future encourages reflection on longevity, impermanence, and the patient endurance of matter across cosmic time. Even when the galaxy ceases to be as bright or active as it is today, these stars will persist, a quiet testament to the slow, deliberate processes that govern the universe. In imagining them, one feels the deep calm of cosmic continuity, a reminder that even as structures change, light and energy endure in subtle, persistent ways. The quiet end of the galaxy's story. Here's something profoundly meditative. In the unimaginably distant future, the Milky Way will reach a quiet end. Star formation will cease as gas is depleted or locked into compact remnants, leaving a galaxy dominated by aging stars, white dwarfs, neutron stars, and black holes. Collisions and mergers will continue on rare occasions, but the overall activity will fade into a tranquil, near-motionless state. The galaxy's spiral arms will dissipate, the halo will slowly disperse, and light itself will become sparse as stars fade. This final phase is not chaotic, but serene, a gentle conclusion to billions of years of activity, a cosmic exhalation after the long, intricate process of galactic evolution. In contemplating this ultimate fate, we are invited to reflect on cycles, impermanence, and the beauty of endings. The Milky Way's story, from a dense, chaotic formation to a tranquil, dim remnant, is a meditation on time, scale, and the quiet poetry of the cosmos, a reminder that all things, no matter how vast or luminous, eventually return to the stillness from which they emerged.